The this keyword is often used in many object-oriented programming languages, and basically this always refers to an object, and that object is typically the one in which the current code is running. Now we will see that there are, of course, some exceptions to that rule. Let's take a look at some examples before we dive into some real code. If we're just trying to print out this within a script tag, you have to remember that JavaScript is running within the global window object that's available in every browser. So if you try to just print out this to the console, it's going to come back with, hey, I'm the global window object, because you're not within any context other than this global object. Now, if you have an object literal, such as person, and you have first name property, a last name property, and then you have a function called full name, now when you use this, this refers to this object literal called person. If you are using a constructor function, such as function person, now when you use this inside of there, that will depend on which object it is. So look at the very bottom down here. I have let p1 equal to a new person. John and Smith is now assigned a first name and last name. So if we were to call the full name function on p1, this refers to p1, and that means those variables, John and Smith. And then I have let p2 equal to new person, Bob and Small. So what does that mean? Well, that means that now those two values are assigned, so this is now in the context of p2. Using this keyword will have different values based on in which context your code is executing. For example, when you're in a method inside of an object, this refers to the owner object. In a function or outside of any function, it refers to the global object or the window object. If you're in an event, it's the element that received the event. Call and apply methods actually refers to the object that's passed in. Now, use strict can also affect this, and we'll see that in this first demo. So let's take a look at using global scope, function scope, and how use strict will change the value of this. Here I have a script tag. In lines 15 through 18, I'm outside of any function. On line 16, I'm spitting out this .toString to the console. So this will refer to the global or the window object. And I'm checking that on line 17 by checking this triple equals window, and that should return a true to us. When you have code outside of any function, then it's going to refer to the global window object. Lines 22 through 25, I have a function. Inside of this function, I'm also spitting out this .toString to the console.log, and again, I'm checking to see if this triple equals window, and that should return a true. Let's go ahead and run this and take a look. Here is the code from the global scoped code, and you can see that it refers to the object window, and this triple equals window is true. Excellent, just like we thought. When I run the function, we also get the global object, and this .window is equal to true. Now, this will change based on whether or not you have used strict in effect, and as I mentioned before, you should always be using this. So let's uncomment this line. Let's save this, and then let's go back and refresh and click on the function. Now you can see that this is now undefined. Just like what use strict is supposed to do, it says, well, I haven't declared anything called this, so it's undefined as of this point. So when you're using this and you're doing just a regular function in the globally scoped namespace, then this does not refer to anything. And that makes sense, and it's actually a good practice to do this. For our next example, let's take a look at what happens with this inside of event handlers. On line 9, I have a button, and I have an on-click event declared inside of there, and I wrote some JavaScript code right in line. And I use this inside of that JavaScript to do this.style.background equals red. This will turn the background of this button red. And why does it do that? Because this, in the context of this event, refers to the HTML element that it's attached to, in this case, the button. On line 12, I have another button where I do onClick equals event handler, passing in this. If you look down on line 20, we receive this in the variable CTL. So this function gets a reference to that button HTML element. And then I can go ahead and print that out in the console.log. Let's go ahead and run this and take a look. So inside of the event handler with inline JavaScript, we can see this does indeed refer to the button. And if we pass this down, we can see again that we are getting a reference to the HTML button. So this, in the context of an event handler, always refers to the HTML element to which it's attached. Our next example, let's take a look at what happens with this inside of an object literal. Here's a function called object literal. What I'm doing is I'm creating let product equal to this object, and in this object you can see some properties like product ID, name, standard cost, and list price. Then we have a function called gross profit. And inside of here, I'm going to access list price and standard cost, which are a part of this object. So we use this. So this, inside of an object literal, always refers to the properties or a method inside of that object literal. And all we're going to do is grab the list price, subtract the standard cost, and that becomes the regular price, and I'll spit that out on line 29 to the console.log. Let's go ahead and run this. And we can see that indeed it does grab that list price and the standard cost, subtracts them, and then applies the currency. Let's now take a look at what happens when we use the call and the apply method and passing in different objects and what happens with this. In this function call and apply, I have the exact same literal object we just saw, where I create product ID, name, standard cost, list price, and this gross profit function. Take a look down here on lines 28 through 31, where I create a new product object called prod2, and I just set a standard cost and a list price. Now take a look at line 34, where I do product.grossProfit. So that says the product object, the literal object that we created that has the gross profit method. Let's go ahead and call that, but we're going to call it using product. Then on line 36, we're going to call product.grossprofit.call, but now we're going to pass in prod2. So this on line 34 will be an instance of product. On line 36, this will refer to product2. So up here on line 21, when we do this list price minus this standard cost, the first one will be the 1431.50 minus the 1059.31. On the second call, it will be the list price of $850 and the standard cost of $500. The apply works the exact same way. I don't have any parameters to pass, and that's the only difference between call and apply, is apply allows you to pass arguments to that particular method. But other than that, you can still pass in which object you wish to use. Let's go ahead and run this just so we can see what it looks like. And there you can see the two different values based on which object gets passed to the call or to the apply. And let's now take a look at what happens with this within constructor functions. Here I have a constructor function that's pretty much the same as the literal object I created earlier. It has a ID, a name, a standard cost, a standard price, and a gross profit function. Now notice the use of this inside of here as well. Well, just like you'd expect, we're also going to try calling this with a couple of different objects. So in our function constructor functions, I'm going to create two different instances of our constructor function. The first one I'm assigning to a variable prod1, and the second one I'm assigning to prod2. They have different IDs, different product names, and different standard cost and list price. On lines 31 and 32, I call the gross profit function on each one of those. So prod1.grossprofit, prod2.grossprofit. As you'd expect, this reflects whichever object we're working with. So prod1 or prod2. Let's go ahead and run this and take a look at what happens. And as you'd expect, we get the different numbers because we're referencing the different objects, and this then takes on the properties of that object.